right. Our next presentation will be by Stephen Elmlinger from Princeton University. He'll be talking about learning and language development in songbirds and human infants and how they are more similar than we might expect.
Okay. Hi, everyone. I'm Stephen Elmlinger, and my work focuses on communicative development. Today I'll talk to you about the social origins of vocal sequence learning, here investigating the development of vocal communication in zebra finches and human infants. So I study the earliest stages of infant communication, and I really study a part of communicative development that doesn't receive much attention, and that's when babies are babbling. So what I mean by babbling are infants' early vocal sounds that gradually become more speech-like over their first year of life. And this development, I'll give you a bit of a sense of here in a second, is actually required to get to adult-like spoken language. So from birth, infants produce immature sounds with a really closed vocal tract. These are called quasi-resonant vowels, and they sound like this. And then around 10 months of age, they're producing clear consonant vowel transitions. These are called canonical babbling syllables, and these contain all of the necessary elements of adult-like speech, and they sound like this. So after this point in development, they're really moving into speaking their first words and continuing on into language development. Other species babble as well. The species that change the acoustics of their babbling as a function of what they hear other members of their species producing are called vocal learners. And we actually compared a couple different vocal learning species that face a similar challenge when they're young, and that is they can't actually take care of themselves. They're altricial species, and they're around adults who take care of them for this protracted period of early development. And they have to learn their communication system rather quickly relative to their lifespan. And learning their species' typical communication during this time helps them not only get their needs met from their caregivers, but to also become part of a larger social system. So both of these learners here on the screen have a similar job in early development, and because their caregivers take care of their survival, these learners are really freed up to deploy their learning resources to learn that job, which is to learn their ambient communication system for birds, to learn to sing, for infants to learn to talk. So for infant vocal development, the main focus is usually on individual syllables. So how infants change from eh to ba over development. Most research is actually focusing on that. But when we talk to each other as adults, we don't just use single syllable words. We actually get really good at stringing multiple words together into larger units which convey more information. We use vocal sequences. And we also figure out how to vocalize faster using these vocal sequences over development. So the question we're going to look at today is, does this really advanced communicative capacity come just from motor development alone, or is the social environment actually guiding this ability? We know that both of these animals learn their vocal sequences, and we want to understand more about where that comes from. In my work, I'm interested in development of complex vocal communication and how it can be organized by simple social interactions. And so where a learner actually vocalizes and an adult responds to that vocalization. For an infant, that might mean caregivers talking back to them. For a young songbird, it might mean social feedback from another bird. And the idea here is that these responses might actually tell the learner something really important, and that is that the sound I just produced had an effect on someone else, which is really what communication is all about. So in this study, we're looking at infants that came into the lab with their caregivers. For these recordings, we can measure infants babbling. They're wearing little wireless microphones attached to their overalls, and we can categorize their sounds into vocal sequences and also individual syllables. And we can measure caregivers' speech that was elicited by these two kinds of sounds. Here's what that interaction looks like. vocal sequence.
Ooh, is the toy box yummy?
And a
You're
response.
chewy with your teeth coming in.
So what we find is that caregivers are much more likely to talk back to infants after they produce a vocal sequence. And this means that infants' vocal sequences are really a potent stimulus on nearby adults, even before they can produce words. Now, based on this, we wondered if social responses to those sequences actually help learners move in a more sequential vocal communicative direction. One parallel across zebra finch and human infant vocal sequences is that they start out being produced quite slow in tempo. And then for an immature learner, it's actually good to go ahead and speed up that tempo because adults in their immediate environment have a tempo that they've come to expect and prefer during communication. And so what we found in the human infants is that caregiver responses specifically to their infants' vocal sequences early on in development actually predicted how quickly infants moved to that preferred tempo. In the zebra finch, we could do a more controlled experiment where the birds would actually elicit feedback from an adult bird on a screen. And the behavior the bird on the screen does is exactly what an adult female would do naturally in the wild after they perceived an attractive song. So in this experimental session, every time a juvenile male would sing, produce a song, my lab mate would actually push a button and trigger a video of what's called a fluff up video in the adult bird. And this is what that looks like. And what we found in the zebra finch, just like the human infants, is that social feedback to song sequences early on actually predicted how quickly the birds moved towards this preferred tempo in mature zebra finch song. And so even for something that we might think of as primarily driven by motor practice, you practice your vocal instrument and you get faster at it, learning how to produce mature temporal signatures of a species' vocal communication is also influenced by social feedback across these two distantly related species here. So it's really possible that evolution hit on social responses to immature sounds as a common solution for these helpless learners. If you're altricial, you do have adults around, otherwise you don't survive. And maybe this is a really common strategy for learning your communication system in the social environment across many more species than we looked at here today. So we'll have to go look at more vocal learners because they might also depend on social guidance to get them up to speed. Thanks for listening. Looking forward to your questions.
That was so cool. Thank you. As we get ready to field the questions from the live stream, you can take some in the room if anyone has them.
Hi, I was curious, what are the implications of this research for like early childhood education or child raising or something like that for parents or caregivers of very young infants?
I think I'm not a clinician or anything, so I would want to be cautious with recommendations. But I think a safe takeaway here is, and I think adults and caregivers already do what I'm about to recommend, but give the learners time to vocalize and hear them out. Try not to interrupt their vocal sequences. Let them, and by doing so, you would let them hear themselves produce that vocal sequence, and then get a sense that, oh, after I do that vocal sequence, I get a response. I think that's probably, if I had to guess, a part of healthy communicative development here.
And then one more question. You mentioned that there's a large number of species that are vocal learners. I was wondering if you had any, if there are any in particular that you think would be interesting sort of models to study in the future.
Yeah, absolutely. So there's a handful of vocal learners, and then like a smaller subset of those, maybe less than 20 taxa that are considered vocal learners. They use the sounds from their social environment to guide the change of their own vocal productions over development. Even a smaller subset within that are socially guided vocal learners. So there's so far as we know, 4 taxa for that. So we've got the human infants, the zebra finch, brown-headed cowbirds, and probably marmosets, so a New World monkey. Going beyond that, I think it would be interesting, the next one on the list might be bats or cetaceans like dolphins and these kinds of things.
All right, we have a couple questions from the live stream. The first one is, what is the zebra finch equivalent to single-syllable human infant vocalizations? Would it just be a sung note?
Okay, this is a great question. I don't think there would be a perfect equivalent, but they do produce calls, right? So the calls in the zebra finch are unlearned, so those don't change over development. Whereas in the human infants, their single syllables do change. They do go from ah to ba, right? Yeah, I think that's the straightforward answer there.
Yes, and it leads me to our last question from the live stream. Do we have any idea what the vocalizations of zebra finches mean?
Oh, no, we do not. As far as I know, and I think the field in general, we have not attributed meaning to zebrafinch song. However, function is a different story. So I think there's going to be mate attraction function, and then there's going to also be social cohesion function for it. But we have not decoded any meaning yet. But it might be there. It might be there.
All right, thank you so much.
Thank you.